Hello, a wonderful shout out to all the students all over the world. Hope you are doing great wherever part of the world you are from, following us from. Welcome to class this evening. Okay, we're looking at the concept of number-based system, and we're going to look at the introductory aspect, introduction to the concept of number-based system. We're going to lay the foundation of number-based system. As we all know, there are various counting systems, various numbering system um, in which are used in mathematics. Among these, we have the we have the place value system, we have the tally system, we have the Roman numeral system, we have the Arabic numbering system, and we have, as of course, we have the number-based system. So with this, we are going to look at the number-based system where numbers are classified, or numbers are classified according to the base that they possess. Okay, according to their bases. Do you understand? Okay, so that's the system of number base. All right, so let's carry on. Now, the number-based system, also known as the numeral system, is a system that uses specific numbers of digits to represent numbers. So it's a system that uses a specific number of digits to represent what? Numbers. So a number can be said to be in a particular base because of what? The number of digits that are being combined together to form that number and the base attached to it. All right, let's carry on. A number-based system is defined by the base it uses. So a number is defined according to the base it uses. All right. The base here being the number of different symbol required by the system to represent any of the infinite series of numbers. So the base here can be a number, it can be a symbol, it can be a letter that is being used to represent the infinite series of number. When we talk of infinite series of number, we are referring to endless series of number. A series of number is usually 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. As a series of number, and so on and so forth. And you say infinite means endless series of number. A base is also a number that when raised to a particular power, that is, when multiplied by itself a particular number of times, as in 10 raised to the power of 2, which is equal to 10 times 10, which is equal to 100, has now, the power has a logarithm equal to the power. It has a logarithm equal to the power. For example, the logarithm of 100 to the base 10 is what? 2. Let me explain. This 10 times 10 is 2. According to the laws of indices, let's go to the board. Okay, just hold on. According to the law of indices, which is according to in indices, when an index is raised to a certain power, when a number is raised to a certain power, and the power is called index. Hold on while I look for this board. All right, so let's hold on. Okay, all right, so we have this. Sorry, just hold on. I'm coming. Let me take this out. Something is all right. Just hold on. All right, now let's carry on. So when you have, for example, you have a to the power of 2. A to the power of 2 is equal to a times a. So a being the variable, then 2 being the index or the power. Okay, so a times a to the power of 2 is simply a times a being the variable, while 2 being the index, or you call it the power. All right, so we are saying here that a base is that number that when raised to a certain power has a logarithm equal to it. So when we say 10 to the power of 2 is equal to 10 times what? 10, which is equal to what? 100. All right. And when you come to logarithm, log 100 to base 10 is equal to what's the power? Is equal to 2. You understand? So that was saying here, or it's equal to what the power there, which is 2. So log 10 to base 10. Sorry about that. That's not it. So what I mean here is that 10 is the power of 2. 10 to the power of 2. Yeah. All right. 10 to the power of 2 is equal to 10 times 10. Yes, equal to 100. So log 100 to base 10 is equal to what? 2, which is what that back to what the power. Do you understand? All right. Let's carry on. Okay. Let me extend this. All right. So let's look at the table. So this table shows the numbers, the and the base and their bases. So we have the number, the name of the base, what is it called, and the base itself. So we have 0, 1. 0 and 1 is simply binary, and binary numbers are numbers that are in base 2. Okay, 0 and 1 are numbers in base 2. The next one is 0, 1, 2. So these numbers are called ternary, and these numbers are in base 3. Okay. The next one is 0, 1, 2, 3. It's called quaternary, and these numbers are in base 4. The next one is 1, 2, 3, 4, 5. This number is quinary. 1, 2, 3, 4. Yes, it's 1, 2, 3, 4. 0, 1, 2, 3, 4. And quinary, and these numbers are in base 5. The next one is we have 0, 1, 2, 3, 4, 5. And these numbers are called quaternary, and these numbers are in base 6. Next one is 0, 1, 2, 3, 4, 5, 6 are septenary, and these numbers are in base 7. The next one is 0, 1, 2, 3, 4, 5, 6, 7, and these numbers are called octal numbers, and they are in base 8. The next one is 0, 1, 2, 3, 4, 5, 6, 7, 8, and these numbers are called nonary, and they are in base 9. The next one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These numbers are called decimal, or they are called denary, and they are in base 10. Then we move further. Ordinarily, in the junior secondary section, we end at base 10, but we are senior secondary, so we move further. So there is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the letter A, and they are called undecimal, and these numbers are in base 11. All right. And we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A and B are duodecimal, and these numbers are in base 12. The next one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, and C, and these numbers are called tridecimal, and they are in base 13. And the next one we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, and D, and these numbers are called tetradecimal, and they are in base 14. The next one 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, and the number I are called pentadecimal, and the numbers are in base 15. And finally 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F, and the numbers are called hexadecimal, and they are in base 16. So we have now identified the various number bases that we have, starting from base 2 to base 16. So let's carry on. The letters may differ in certain textbook. Majority of the textbook uses the letter A, B, C to F. Some uses other letters. Okay, but if other letters are to be used, the textbook must specify what each letter stands for. You understand? So in case your textbook you're using is they use T, they use M, they use V, they use N, they must specify what T is. They must specify what M means. They must specify what other letters means. Or do you understand? For here now, A, we know that A is referring to base 11, B referring to base 12, C referring to base 13, D referring to base 14, E referring to base 15, and F referring to base 16. All right, let's carry on. Now, conversion from any base to base 10. So numbers in their natural form are in base 10. Okay, numbers standing on their own without any base are in base 10 in their natural form. I don't know if you're getting what I'm saying. Numbers in the natural form are in base, except a base is attached. That's when it is now classified to be under that base. So a number in the natural form is classified to be in base 10, apart from 0 and 1. 0 and 1 are naturally in base 2, but any other number from beyond 0 and 1 are naturally in base 10. But in the case that bases are being specified, a basis is being attached, that means it's specified that this number is in this so base. Do you understand what I mean? It can be, let me show you an example. There are in certain cases, I will take this out. There are certain cases. Hold on. Okay. There are certain cases where the number, okay, I'll take it off again. There are certain cases where the number 123 is said to be in base 4, and there are certain cases where the number 123 is said to be in base 10. Do you understand? Now, if the number is without any base attached to it, let's say it is just like this, okay, it's said to be in base 10. Do you understand? As long as there's no base attached to it, the natural form is base 10. But once you see 4 here being attached, it simply means this number is going to be classified. It's going to be classified as a number, a base 4 number. I hope you understand. Okay, let's fire on. So now let's read. 2-digit 0, 1 suffice to represent a number in binary system. So 0 and 1 are number in binary system, and they're in base 2. 6 digits 0, 1, 2, 3, 4, 5 are needed to represent a number in hexadecimal or binary number. That numbers that are in base 6. Yes, 6. Then and 12 digits 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, which is base 10, and B, which is base 11, are needed to represent a number in duodecimal, which is base 12. Okay, let's carry on. The number 3, 0, 1, 5, 5 in the sexagesimal system is the number 3. That's conversion, to convert. Okay, to carry out conversion, that means you are converting from other bases to base 10. When you are converting from other bases to base 10, you do what you call expansion. Okay, you will expand the number by multiplying the number by the base and raising the base to the power. Okay, raising the base to the index. Do you understand? As we have here, let me show us from the board. So we have 30155, 30155. Let's expand this. Okay, from the board, 30155. So we have 30155 is equal to so the base is the power here. The first number here is 0, the second one is 1, 2, 3, and 4. Sorry, I'll take that out. 4. So this the number you're seeing up here are simply the powers. All right, so we have 3 times, what is the base? Let me check the base they gave to us. Sorry, I didn't get the base before. So the base is base 6. All right, so this number is in base 6. The number is in base 6. Sorry, the number is in base 6. Number is in base 6. So we have 3 times 6 raised to the power of 4 plus 0 times 6 raised to the power of 3 plus 1 times 6 raised to the power of 2. Please take the notes. I will shift this. Take the note. I will shift this. Pause the video and take your notes. So I will shift. All right. Plus, okay, where did we stop? Okay, 5. So we have 5 times 6 raised to the power of 1 plus 5 times 6 raised to the power of 0. So for this, you have expanded this b according to what? To the base. You carry out the expansion. So with this, from this expansion, we can now simplify to get a single number, which will be to get a number, a definite number, which should be in base 10. Okay, so when you're converting from base 10 to other bases, you use the method called expansion. Sorry about that. Let me take it out. Okay, you use expansion. When you're converting to base 10, you use expansion. When you're converting from base 10 to other bases, you use repeated division. Sorry about that. Let me shift it. Yes, repeated division. That is, if you're converting from base 10 to any other base, you use repeated division. When you're converting from any other base to base 10, you use expansion method. Okay, all right, let's take this off. Let's take this off. Let's take this off. Okay, let's take this off. All right. Let's go back to our board, to our notes. All right. Now, so also in the decimal system, the number 2AB in the duodecimal system is the number 2. Yes, 2. The base here is 12. Base 12. Duodecimal is 12. So the base here is 12. So we have 2 times 12, which is the base, to the power of 2, plus 11 times 12 to the power of 1, plus 10 times 12. The A. Remember that in the numbering, as we did from our table, B refers to 11, then A refers to 10. Okay, do you understand? So that is it. That is it. So the number now as it is in base what? Base 12. Okay, so let's solve this. Now, so to convert from any base to base 10, expand the given numbers. I told the expansion in the powers of their bases and simplify. So we expand the given number in the power of their bases and then simplify. Let's solve. For example, convert 1243 but in base 5 to base 10. Convert 1243 base 5 to base 10. So let's go to our board. So I'll get my pen. Example 1. Convert 1243 base 5 to base 10. Please take the question. I will shift it so that we can have space to write. All right, so let's carry on. Okay, so solution. Now, take it down, shift it a little again. Let me take it down a little. So 1243 base 5. 1243 base 5 is equal to, so you come to the number, then let's sort out the base, the powers. So the first one, the last number here is 0. Start from 0. The second last to the last 1. 1. The third to the last 2 and 3. All right, 0, 1, 2, 3. All right, let's carry on. Let's carry on with the solving. So 1, 2, 4, 3. All right. So we have. Sorry. I'll take this out. Let's come back here. All right. So 1 times the base is 5. 5. What's the power? The power there is 3. So at the power of 3. Sorry, let me take it clearly. The power of 3 plus 2 times 5 at the power of 2 plus 4 times 5, sorry, at the power of 1 plus, sorry, let me just take it out so I'll write it neatly. All right. Okay, plus 4 times 5 at the power 1 plus 3 times 5 at the power 0. All right, so let's carry on. Pause the video and take it a note. All right, now let's simplify that. We have expanded. Let's simplify now. So we have 1 times 5 raised to the power of 3. That's 5 times 5 times 5. 5 to the power of 3. 5 times 5 times 5. Let's go to our calculator. Okay, the calculator. If we have the scientific, fine. Where is the calculator? Okay, yeah, my calculator. Okay, so we see 5 to the power of 3. 5 to the power of 3. Let me take this out. 5 to the power of 3 simply 5 times 5 times 5. That is 125. So you come back to your board. Sorry about that. Let me get this straight. Sorry. So we have 1 times 125. 1 times 125. Okay. Plus the next one, or the next number there. 2 times 5 to the power of 2. That's 5 times 5. So 2 times 5 times 5 is 25. Plus 3. Okay. Plus 3 times 5 to the power of 1. Sorry about that. Is it 3 or 4? Okay, 4 first. 4 first. So 4. 5 to the power of 1 is the 5. Any number to the power of 1 is the same number. Plus 3 times 5 to the power of 0 is 1. Any number to the power of 0 is 1. That is zero index law. State that any number to the power of 0 is simply 1. Okay. Let's fire on. I will shift this a little up. Okay. Now, sorry, let's come down. Okay, so 1 times 125 is the 125. So, sorry. Take this out. All right. 1 times 125 is the 125. So let's shift a little. 1 times 125 is the 125. So So we have 125 plus 2 times 5, 2 times 25 is 50, plus 4 times 5, 4 times 5 is 20. I'll take it up a little. Plus 5 times, let me take it down. 3 times 1 is 3. So now let's total everything. 125 plus 50 plus 20 plus 3. 125. Let's go to the calculator. 125 plus 50 plus 20 plus 3. We have 198. So we have equal to 198, and this number is in base 10. That's what I'm converting to base 10. So that is your answer. So that's basically it on expansion. That's basically on expansion of number bases. So that is basically it. That's how to carry out conversion from other bases to base 10. Is that simple? Simply expand the number by multiplying it by the power of the base, then simplify. You simply have your answer. All right, so that is basically it. That is the solution to the answer. All right, let us carry on. Okay, sorry about that. Let us go to let's take another example. So let's take another example. Hope you are understanding. If there's any question, feel free to ask in the comment section or reach out to me privately. Now, example 2, convert convert 3AB, and this number is set to be in base 12. All right, to base 10. Convert 3AB base 12 to base 10. All right, let's fire on. All right, so solution. solution. So we can simply have 3ab is equal to, so let's sort out the powers. The on top of b is 0, on top of a is 1, on top of 3 is 2. So we have 3 times, the base here is 12, so 3 times 12 raised to the power of 2 plus the number a from our table is under which number. Let's check what the number a represents. The number a represents 10. Okay, number a represents 10, so a represents 10, b represents 12, sorry, b represents 11, c represents 12, d represents 13, e represents, and so on and so forth. Okay, so let's carry on. So the number a is 10, so we have 10 raised to the power of what? 1. I'll take it up, plus is 10, sorry about that, not take the power of 1 is 10, let me take this, plus 10 times 12 to the power of 1 plus b is 11 times 12 raised to the power of 0. Okay, so with this you can simply say, take it up, right, let me take it down a little bit. All right, so 3 times 12 raised to the power of 2, 3 times 12 to the power of 2 is 144. That is 12 times 12, 144, so equal to 144 plus 10 times 12 to the power of 1 is to 12. All right, plus, take it up a little, 12 times 12 to the power of 0 is still 1, and number to the power of 0 is 1. So let's carry on. It is equal to, I'll take it up a little, equal to 3 times 144. So let's go to our calculator. 3 times 144. 3 times 144. So let's take this out. 3 times 144. The answer is 432. 432. So you come down here, you take 432 plus 10 times 12. 10 times 12 from the calculator. We take this out. 10 times 12, 120. So we'll come back. We have 120 plus 12 times 1 is to 12. So now let's total everything. Totaling this 143 plus 120 plus 12, 143. So let's take everything out. 143 plus 120 plus 12. The answer is 275. 275. So it's equal to 275 base 10, and that is the answer. So it is that simple. Take it step by step, expand it in step by step, and you'll be able to simplify. When you simplify, you get your definite answer, and the answer is definitely going to be in base 10. Okay, so that is that concerning conversion from base 10 to other bases. All right, so if there's any question, you can reach out, you can drop it in the comment section. If you require more examples to be done, please drop a comment on the comment section, and more examples to be done on that subject matter. All right, let's carry on. For lack of time, let's carry on. So I'll shift a little. We're looking at conversion now. Conversion from base 10 to, okay, sorry about that. Conversion of decimal numbers, decimal fractions let me take this decimal fractions. Decimal fractions to base 10. Conversion of decimal fractions to base 10. Conversion of decimal fractions to base 10. So in this, we are going to look at how numbers that are in decimal, because what we did here are whole numbers. Now we're looking at decimal numbers, decimal fractions. And that fraction is a part of a whole number. For example, 1/2, which is 0.5, is a part of a whole number, and so on and so forth. So let's carry on. Okay, so let's see. Well, the same method I'm going to use, the same conversion, the same expansion. So you expand, then you simplify. Let's carry on. So example, we have said convert 1011.111. This is in base 2 to base 10. All right, I will take this up a little. So we have solution. Convert 1011.111 base 2 to base 10. So we have, okay, I will shift it a little. Okay, so I'll take it down. Let me see the question. Okay, 1011.111 base 2 is equal to, so we're going to convert this. The number is in binary. Let's convert to base 10. It's a decimal number in binary. Let's convert to base 10. So we're going to sort out the, sorry about that. I will come back again. Solution. All right, I'm going to sort out the powers. So before the point, so this numbers, these are the number are whole numbers. Okay, these are these are decimal. So this is a decimal point. All right, so every number from the decimal point to the left, you're going to start counting. The first number here is 0. All right, the whole numbers. This is 1. Okay, and this is 2, and this is 3. Then we want to move after the decimal. You're moving to the right, this side of the number. So this is going to be -1. Yes, because it's decimal. The next one is -2. Sorry. So we have -2, and this one is -3. All right, that's the powers. All right, let's carry on. Is that very simple? There's no big deal about it. So let's shift it a little. So this is equal to, yeah, so we have the number is, the base is base 2. So let me take this thing out. All right, so we have 1 times 2 raised to the power of what? 3. That's the power there. The power there, you can see the power there is 3. Yeah, so plus 0 times 2, which is the base, to the power of what? 2, plus 1 times 2 to the power of what? 1. I will take this up a little. Plus 1 times 2 to the power of what? 0. Plus 1 times 2 to the power of -1. Plus 1 times 2 to the power of -2. I'll take this a little up. Okay, sorry about that. All right. Then plus 1 times 2 to the power of -3. All right, so let's carry on. So this is our expansion. This is our expansion. This is our expansion. All right, it's equal to, so 1 times, let's simplify, 1 times 2 to the power of 3, that is 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So we have 8 plus 1, sorry, not 1 is 0. So 0 times 2 to the power of 2 is 4. Right, 2 times 2 plus 1 times 2 to the power of 1 is still 2, plus 1 times 2 to the power of 0 is 1, plus 1 times, you can decide to use calculator to punch, but let's leave the answer in fraction, in mixed fraction. So that 1 raised to the power of minus 1, it can be written as 1 over 2 raised to the power of 1. Okay, that is when a number is raised to a negative exponent, you are going to take the inverse of that number. Okay, the inverse of that number with the exponent is the power. So when a number is raised to a negative power, you are going to take the inverse of that number. All right, so 1 over 2 is the inverse of 1 to the power of 2 to the power of what? Minus 1. All right, let's carry on. Okay, so let's carry on. Now we have the next one is 1 times 2. Sorry. Okay, 1 times 1 over 2 to the power of 2. So when you are taking the inverse, you take out the negative, the minus. Okay, you take out the negative number that is before the exponent, that is before the power, then plus 1 times 1 over 2 to the power of 3. Okay, to the power of 3. All right, so we have this. So let's go back again. This is our expansion that we did. Expansion. Okay, expansion. All right, let's carry on. So 1 times 8 is equal to what? Is equal to 8 plus 1 times 0 times 4 is 0, plus 1 times 2 is 2, plus 1 times 1 is 1, plus 1 times 1 over 2 to the power of 1 is still 1 over 2. All right, 1 times 1 over 2 to the power of 1 is still 1 over 2. So plus, I'll take it up, plus 1 over 2 plus 1 times 1 over 2 to the power of 2. 2 to the power of 2 is 1 over 2 to the power of 2 is 4. That's 2 times 2, plus 1 again. 1 times 1 times 1 over 2 to the power of 3. So 2 to the power of 3 is simply 8. That's 2 times 2 times 2. So that's what we have. Now let's carry on. Okay, so 8 plus 2 plus 1, that is 11. So we have 11 equal to 11 plus, you don't just say 1 plus 1 plus 1. No, you're going to take the LCM of the base of the denominator of 2, 4, and 8. The LCM here is simply the number that these 2, 4, and 8 can divide without a remainder. All right, and the number here is always is larger. Is a large number here. The largest. So you can check here. You can check 8 is the largest number here among them. You check which of them is the largest. 8 is the largest number, right? So you're going to say, can 4 divide 8? Yes. 8 divided by 4 is 2, right? Yes. So you can go. You check again. Can 2 divide 8? 8 divided by 2 is what? 4. So there's no remainder. So it's perfect. So 8 is the LCM. Yeah. But had it been, let's assume here is 7, for example. If here becomes 7, if here is 7, you cannot use 7 because 4 divided by 2 is possible, but 4 divided by 7 is not possible. 7 divided by 4 is not possible. So for you to get the LCM, simply multiply the three numbers. Okay, multiply 2 times 4 times 7. In the case that the denominators cannot be divided, no denominator here, the larger denominator in the equation, that the larger denominator is not divisible by the other denominators. Okay, so for this case 8, which is the larger denominator here, is divisible by 4, is divisible by 2. All right, so 8 becomes the LCM. So we have 8. Now let's do this. So it's going to be 8, this 8, 8. So it's going to be 8 divided by 2, 8 divided by 2, 8 divided by 2, 8 divided by 2. The answer is 2. So let me take these things out. Oh, sorry, took out the 2. Okay, so let me show you how we do this LCM of a thing. So we're going to be this 8 that is down here, 8 divided by 2 times 1. Okay, they just bear with it. So whatever we do it, that's what I mean. The same thing with 4. There's no space for me to continue. Okay, let's carry on, no problem. I will just need to shift the board. It's okay. So we have the same thing plus 8 divided by 4 times 1, close bracket again, right? Sorry, plus 8 divided by 8 times 1, close bracket. All right, so this is it, the division sign. So let's come back here. Let's come back. So we have equal to 11. What is happening? Sorry, equal to. So equal to. Are we getting to the end of the board, or what is happening? We're going to the end of the board. Okay, please take this thing, take it down. After that, I can erase. Okay, let's see if I can move to the other side of the board. Okay. All right. Let's see. So this is simply equal to 11 plus, now come back here, 8 divided by 2 is 4. 4 times 1 is 4. So we have 4 plus 8 divided by 4 is 2. 8 divided by 4 is 2. 2 times 1 is still 2. So you come back. 2 plus 8 divided by 8 is 1. 1 times 1 is 1. Okay. 1 all over what? 8. This is simply equal to 11 whole number plus 4 plus 2 is 6. 6 plus 1, 7. So we have 7 all over 8. They can be simply written as equal to 11 whole number 7 over 8. So that's the answer. And this is in base 10. That is the answer. So this is, you can choose the same answer. You can choose to use calculator to solve it with calculator, and you will get the answer in decimal. So to get it to convert it to decimal is very simple. Change it to mixed fraction, then divide. You are gonna have your answer. That if your answer is being left, you have to leave your answer in decimal. To leave your answer in decimal, you simply use calculator. Okay, let's do that. Let's see. So please pause this video, take this note so that I can take off this, or let me just see if it will go. Okay, the board has come to the end of the board. So let's solve it. I will take this part of the board out, so please pause the video. Sorry, pause the video and take the notes. I'll go back over it again just in case you miss anything. Here is it. Here the solving, here the LCM part. Sorry, this should be plus. Sorry about that. This pen, this should be plus. Yes. And this is it. Okay, so I will cancel to this point here. I will cancel to a certain point, then we'll continue from there. So let me take out this part. So you have taken the note. Take out this part. Okay, now if you decide to use calculator, we're going to have 11 plus 1 times 1 times 1 times 2 to the power minus 1. So you come to your calculator, you press calculator 2. Your calculator has raised to power. This is phone I'm using, so I'm using a phone, so it may not be the same with what I have. So 2 raised to power. So here's my raised to power. Raised to power of -1. The answer is 0.5. Okay, 0.5. So I have 0.5 there. That one has go back. I'll have 0.5 plus. I'll come out to my calculator again. I want my calculator. So I have 1 times 2 again. 2 to the power of 2. Sorry, 2. This is my raised to power. Sorry about that. 2 raised to power. Yes. 2 raised to power of -2. The answer is 0.25. Answer is 0.25. So 0.25 plus. Okay, next one. 2 raised to the power of -3. 2 raised to the power of -3. That is 0.125. 0.125. So 0.125. So now you simply just do arithmetic. Do your simple arithmetic. 11.0.5 plus 0.25 plus 0.125. So let's carry on. So let's add 11 plus 0.5 plus 0.25 plus 0.125. You have 11.875. 11.875. So come here is equal to 11.875 base 10. That is it. So that is the answer. That is if you want to solve it and leave your answer in decimal. When you solve it and leave your answer in mixed fraction, you follow the other method we use. So this method is quite short, but if it's theory, yes, you may use decimal and you go. But if it's an objective question, it may be difficult. Reason being that the answer may likely be left in mixed fraction, and if the answer is left in mixed fraction and you solve it in decimal, you may have problem converting it, finding which of them is the answer. Okay, so that's why I solved the two methods. So you could, if the answer is left in decimal, you know where to go, how to get the answer. If the answer is left in mixed fraction, you know how to get the answer. So I hope you understand. Please go through it over and over. If you have any question, drop in the comment section. If you desire more examples to be done on this, do well to reach out to me. Do well to drop your comment in the comment section. And this is it from here. So today, we draw the curtain for today. So from Cordage Virtual School, from the decks of Cordage Virtual School, we sign out for now. Bye for now.